Welcome to the deep dive. Today, we're jumping into something pretty significant in AI hardware.
We are indeed. Google's new 7th gen TPU, the Tensor Processing Unit. They're calling it Ironwood.
Ironwood. Okay. And this feels like a big step, right? We want to give everyone a fast track to understanding what it really means for AI.
Exactly. We've been digging through everything released around the Google Cloud Next conference back in April 2025.
Right.
So our mission today is basically to unpack Ironwood.
hmm
What is it? When did it come about? What does it actually do?
Who gets to use it and how?
Yeah, and who are the competitors out there? What makes this one different? And, maybe a little peek into the future.
Perfect. For everyone trying to stay sharp on tech, this feels like a need to know. So let's start at the top. What is Ironwood, fundamentally?
Okay, so it's Google's 7th generation of these custom chips, the TPUs. But the real key thing here, the main focus, is inference.
Inference. Okay, refresh us quickly on that.
Sure. Inference is, it's the stage where a trained AI model actually gets put to work, making predictions, decisions, using what it learned in the real world.
Ah, okay. So if training is like the AI going to school,
Yeah,
inference is it actually getting a job and doing stuff?
that's a perfect way to put it.
Yeah.
And that's the big shift. Earlier TPUs, they kind of did both, right? Training and inference.
Uh-huh.
Ironwood, it's engineered, like laser focused just on inference.
Which tells you something about where AI is heading, doesn't it? Deployment is becoming critical.
Absolutely. It shows how important it is now to run these models efficiently out in the wild in actual applications.
Makes sense. AI is definitely moving out of the lab. Now, hardware this complex doesn't just pop up. What's the backstory? When was it developed?
Right, it's not overnight. Google started this whole TPU journey way back in 2016.
2016. Okay.
Yeah. So Ironwood, announced April 2025, is really the product of, well, nearly a decade of R&D, learning from each previous version.
Building on past lessons.
Exactly. And timeline-wise, for folks wondering, Google Cloud customers should start getting access late 2025.
Almost 10 years in the making. That's serious commitment. Okay, let's get into the juicy stuff. What makes it tick? The features, the power.
Okay, the power numbers are, well, they're pretty staggering. Each chip, just one Ironwood chip, hits 4,614 teraflops.
Teraflops, okay.
But then you scale it up. A full pod, that's 9,216 chips together.
Ooh,
Yeah, that delivers 42.5 exaflops.
exaflops. And I mean, can you even put that number into context? It sounds astronomical.
It kind of is. Google actually gave a comparison. They said that's more than 24 times the compute power of El Capitan.
Which was the world's fastest supercomputer.
Exactly. So think massive processing power, but specifically tuned for running AI models fast. It opens doors for really complex AI in real time.
Incredible leap. But with all that power comes the question of, well, power consumption, energy efficiency. How's it look there?
That's super important. And another big win for Ironwood, actually. It's nearly twice as power efficient as Trillium, the previous gen.
Twice as efficient. Okay.
And get this. Compared to the first cloud TPU from 2018, it's almost 30 times more efficient.
30 times in what, 7 years? That's huge. How do they manage that?
It's a mix of things. Better cooling, for one. They're using liquid cooling, which helps a lot.
Yeah.
And also just smarter chip design, really optimizing power management right down at the microarchitecture level.
So clever engineering, not just brute force.
Right.
Okay, power, efficiency. What about data? AI needs to chew through data fast. Memory, bandwidth.
Absolutely vital. Each chip packs 192 gigabytes of high bandwidth memory HBM.
192 gigs per chip.
Nice. And the bandwidth is huge. 7.4 terabits per second. That's like way more capacity and much faster pipes for data compared to older versions.
So data gets to the processing cores much quicker.
Exactly. Less waiting around,
Hmm.
which means faster processing, lower latency. Crucial for those real-time AI applications we talked about.
Right, things where a delay is a big problem, like, I don't know, live translation or maybe self-driving systems.
Precisely.
Yeah.
Or financial fraud detection, interactive assistance. Anywhere milliseconds make a difference. Better memory and bandwidth stop things getting bottlenecked.
Makes sense. And you mentioned those massive pods. How flexible is it? Can you use fewer chips if you don't need an exaflop?
Oh yeah, definitely designed for scalability. You get smaller setups, maybe starting around 256 chips in a cluster, all the way up to those giant 9,216 chip pods.
Okay.
So it adapts. Small AI jobs, huge complex ones.
Yeah.
You can configure the right amount of power.
This sounds incredibly potent, but who gets their hands on it? Is this something chip enthusiasts can buy?
Slight chuckle. Not quite. While the tech will definitely impact the AI we all use eventually, direct access is for Google Cloud customers.
Okay.
And of course, Google's own internal teams use it heavily. It's not like you can buy an Ironwood card off the shelf.
Right, it's infrastructure. So for those Google Cloud customers, how do they actually use Ironwood? What's the interface?
They tap into it through Google Cloud's AI services. Think platforms like Vertex AI, AI Studio,
Oh.
those kinds of tools.
Ah, so it's integrated.
Deeply integrated. Google provides the APIs, the tools,
Yeah.
everything needed to deploy and manage your AI models on Ironwood without needing to mess with the bare metal yourself.
Got it. It's the engine running under the hood of their cloud platform. Now, Google's obviously a big player here, but they're not alone in building custom AI silicon, are they? Who else is in this race?
Oh, absolutely not. It's a very hot area. You've got NVIDIA, obviously the big one. Their GPUs are everywhere in AI for training and inference.
The dominant player, for sure.
Then there's AWS, Amazon. They've got their own custom chips too. Training for training, and Inferentia specifically for inference.
Right, Inferentia. Similar focus to Ironwood, then.
Sort of, yeah. And Microsoft Azure is also investing heavily. They have chips like the Maya 100. So, yeah, it's a really competitive space pushing innovation fast.
Okay, so against giants like NVIDIA and the other cloud providers with their own chips, what makes Ironwood stand out? What's Google's angle here?
Good question. I'd say a few key things. First, that laser focus on inference.
We keep coming back to that.
Right. Because it's important. While others might offer chips that do both jobs, Ironwood is purely optimized for running models that are already trained. That specialization could mean better performance, better efficiency, specifically for deployment.
So it's a specialist, not a generalist.
Kind of, yeah. Second is Google's vertical integration,
Meaning?
meaning they develop the hardware, the Ironwood chip itself, and a lot of the software that runs on it, like TensorFlow.
Ah, the whole stack.
Exactly. That tight connection between the hardware and software allows for really deep optimization, potentially smoother, faster performance than mixing and matching components.
That makes sense, designing everything to work together from the ground up. What's the third point?
The third is that blend of massive scalability and that energy efficiency we talked about.
Right, the exaflops and the low power draw.
Precisely. Being able to scale up to handle truly enormous AI tasks while keeping energy use relatively low is a huge deal, especially as people worry more about sustainable AI and keeping costs down.
So scalability plus efficiency is a major selling point. Looking forward then, what does Ironwood signal about where AI hardware is going?
I think it really highlights this strategic shift towards efficient, scalable inference that's becoming the bottleneck or maybe the next big frontier. As AI gets baked into everything, you need hardware optimized for just running it everywhere, all the time. Google's betting big on that demand surging.
So we'll see more specialized chips.
It seems likely.
Yeah.
More focus on tailoring hardware for specific parts of the AI workflow, especially inference.
It really feels like we're moving past just building the AI models and now focusing heavily on how to run them efficiently and affordably everywhere.
Couldn't agree more. Deployment, getting AI out there quickly, reliably, sustainably, that's becoming absolutely key for widespread adoption.
This has been really illuminating. Ironwood isn't just another chip upgrade. It feels like a statement about where Google sees AI infrastructure heading.
I think so too. The focus on power, efficiency, scale, all for inference.
Yeah.
It shows how practical deployed AI is maturing.
Okay, so let's do a quick wrap-up. Ironwood. Google's 7th gen TPU, built over almost a decade, announced April 2025. It's big deal. Optimized purely for AI inference.
Right. Huge compute power, up to 42.5 exaflops in a pod. But also big gains in energy efficiency, nearly 30 times better than their first cloud TPU.
Plus, lots of memory and bandwidth per chip, accessible via Google Cloud platforms like Vertex AI.
And competing against NVIDIA, AWS's Inferentia, Microsoft's Maya, and others.
But standing out through that inference focus, the tight hardware-software integration.
And that combination of massive scale and efficiency.
It really positions Google strongly for the growing need for efficient AI deployment.
Definitely. Which leaves us with something to think about, right? As inference gets more and more crucial for the AI we use every day, how is this hardware specialization going to change the types of AI we interact with? And what does it mean for who gets access to this kind of power?
Really interesting questions. Definitely food for thought. Thanks for breaking all that down.
My pleasure.
And for everyone listening, if you're keen on staying updated with AI tech, our next episode drops tomorrow evening. Until then, keep exploring.